In this lesson, we're going to be stating domain and evaluating radicals. What does it mean to evaluate a radical? Basically means that you're going to have some sort of an equation. So for example, we'll have f of x is going to equal the square root of x minus 6. And they're just going to give you a couple of values to plug in. And you plug it in, see what happens. So f of 10 basically means that wherever you have a variable in that equation, you're going to replace it with 10 and reduce it down or simplify your equation as best you can. So this is going to be the square root of 10 minus 6, which becomes square root of 4. So f of 10 is the square root of 4, and the square root of 4 becomes 2. So f of 10 is getting you 2. So this is your x value that got plugged into the equation. This is your y value that's coming out of the equation. So let's do a couple more. So f of 8 equals the square root of 8 minus 6. It's telling us what we're plugging into the equation. Plug an 8 in. 8 minus 6 is going to be 2. And we can't square root that other than making it a decimal, so we can leave it like that. So if we do another one, let's say we plug in a 6. You'll have square root of 6 minus 6. So that's going to turn out to be 0. So the square root of 0 is 0. So f of 6 equals 0. Again, this is your x value. This is your y value. So let's do one more. Let's plug 4 into the equation. 4 minus 6 turns out to be negative 2. And f of 4 is going to equal negative 2. Now, as of right now, we're not going to be dealing with imaginaries or non-real. So right now, we'll basically call that undefined. Eventually, we'll be able to square root the negative and deal with that a little bit, depending upon the numbers. All right, the next thing we want to do is talk about domains. There are certain numbers that we were able to plug in okay into this equation, but then there are certain numbers that we can't. Well, we want to generalize that and talk about what exactly can we plug in and what can't we plug into this equation. And that is talking about domain. So we will be stating the domain. All right, so if we go back to that original equation, we have f of x is equal to the square root of x minus 6. What numbers are okay to plug in and what numbers are not okay to plug in? So clearly 10 was okay to plug in, 8 was okay to plug in, even though we didn't get a perfect square. 6 is okay to plug in, but 4 isn't. So where is that line? 4 caused a negative inside the square root. We don't want square roots to have negatives. So how do we determine where that line is, what we can and cannot plug into it? That is talking about domain. What can you and can you not plug into this equation? So for this one, it's all about this square root. The square root cannot be negative. So we'll take this piece inside the square root, and if it needs to not be negative, it can only be positive, but you can also square root 0. So every single time, we're going to set it greater than or equal to 0, because no matter what you plug in, this has to be, after you subtract 6 from whatever you plug in, has to be greater than or equal to 0. So this is our setup every single time, and then we'll solve it. So we'll add 6 to both sides, add 6 to both sides. X is going to be greater than or equal to 6. So our domain, I'll abbreviate it with D, is all values that are greater than or equal to 6. So we'll put it in interval notation from 6 to infinity. And those are the values that are okay to plug into our equation. So we're going to look at a graph on this and get a visual of what's happening. So we have a graph, and we're going to graph the first equation. So it looks like that. So that's what the square root of x minus 6 looks like. So as you see, the graph doesn't exist over here, because the graph is only going to exist where we have positives inside the square root or 0. So 6, we're going to start at 6 and go to infinity, which basically means your domain is the horizontal aspect of the graph. So our x's can be 6 and greater plugged into the equation. And when we plug them into the equation, these are the y values that we get out of it. But if you notice, there's nothing to the left of 6. So it starts at 6 and greater. And we will include the 6. All right, so let's do 2 more of those. A little more complicated as we go. So let's do a second. Let's say this time your f of x is the square root of 2x plus 3. All right, so same exact thing. This needs to make sure that it's a positive. So we're going to take whatever's on the inside of our square root and say that it needs to be greater than or equal to 0. So we'll solve for x. We'll subtract 3 over to the other side. We'll have 2x is going to be greater than or equal to negative 3. Divide by 2. X is going to be greater than or equal to negative 3 halves. And negative 3 halves is negative 1 1/2. So let's turn that graph on. In that graph, our x values are going to start at, zoom in a little bit, start exactly at negative 1 1/2 and anything to the right, just like our domain is staying. So our domain are from negative 3 halves, which is negative 1 1/2, and anything greater than it. And that's where the x's, those are the x's that are allowed to plug it into this equation, making sure we don't have negatives. All right, one last. So we'll say that it's a different function. G of x is going to be the square root of negative 1/2 x plus 4. And exact same thing. Make sure that that 4 is inside the square root. So exact same setup. This needs to be a positive after you've multiplied whatever that value is by a negative 1/2 and you've added 4 to it. So the same setup every single time is the piece inside the square root needs to be greater than or equal to 0, and we solve. So we'll subtract 4 on both sides. Negative 1/2 x is greater than or equal to negative 4. This time, to get rid of this, we could divide by a negative 1/2, or just as easily, we could multiply by its reciprocal. But we got to keep the negative on there, so a negative times a negative will make a positive, and then half of 2 is 1. And anytime you multiply or divide by a negative, your inequality is going to switch. So that's going to become a less than or equal to, and this is 8. All right, so as far as domain goes, we want x's that are going to be less than or equal to 8. If we plug in those values, apply the negative to it, and add 4 to it, that's going to keep everything positive or 0. So our graph on this one is going to be, if you kind of think of a visual, we're going to be having those types of values. Now that's not the graph of it, that's just kind of a number line of just this. So our values that we can plug in are going to come from negative infinity and stop at 8 inclusive. All right, so that is just to purely help me create the domain. So what does it actually look like for a graph? So the square root of that. So that one should start at 8, which this is 8. And it's going to go to the left because our graph is actually coming from negative infinity and stopping at 8. And anything greater than that is going to cause us to have a negative inside the square root. So our graph on that one is going to look like that. And that was stating domain and evaluating radicals.